So now we have two equations in two unknowns. And we can see that along our first equation here, there are many, many points that make that equation true. So this is the red equation. It's negative 2x plus y equals 3. Millions of points that make that equation to come out to be equal, the left and the right side. We have 0, 3 here. We have negative 1.5, 0. Now, for our other equation, 5x plus 5y equals 0, there's another set of ordered pairs. All of these ordered pairs make that second equation true. So we have 0, 0 makes it true. We have negative 2, positive 2 makes it true. But then we have this very unique point right here that is on both lines, and both of those equations are satisfied by this point right here, negative 1, 1. Isn't, okay? We see that very special point, negative 1, 1. And so we have an x value of negative 1 and a y value of 1. And if we plugged those into either equation, they would come out true. Both equations would come out true with this same point. And so that point is the solution of this equation. The x would be negative 1 and the y would be positive 1. And so if we went and we solved this system of equations algebraically, which we just did a little bit ago, we would get x equals negative 1. We would get y equals positive 1. So here you see how you can solve a system of equations just by graphing them. And you find the ordered pair where the two lines cross, and that is your solution. So when you are solving a system of equations, sometimes the easiest way to do it is just to graph the lines and look at where they cross. Now, that's going to be a problem if you've got decimals that are, say you have a decimal that is repeating and you don't know the fraction that goes with it, and your homework system might be asking for a simplified fraction. So then you would need to use the algebra to get your answer. But here on this problem, we could have easily just solved it by graphing. The answers are negative 1 and 1, and we're done.